everybody. So obviously I'm out today for different work I have to do for the district. So you're watching this video to do your notes. So you should have from the sub new packet. We are now in Unit 2. So if you go on my Canvas page, I've had various buttons that say like Unit 1 and Unit 2. We are now in Unit 2. So if you're ever absent, suspended, field trip, sick, whatever, and you want to stay caught up on things, because this packet says Unit 2, you should be clicking the button that says Unit 2. Inside that button, it's going to have a list of a whole bunch of videos that will kind of teach you what's happening for individual problems. Now, it's broken up into like different parts, okay? Since we are Unit 2, your button is Unit 2. Since we were Packet 1, think of that as Part 1. So if you're ever, for whatever reason, absent, that's how you can keep up in this unit, okay? So let's get to it. We'll start this video and then we'll do, I don't know, you'll take your notes. Great. So we're going to go back to transformations. And, well, I should back it up a little bit. This unit is called quadratics. So you have dealt with quadratics. That is anytime you have a function like y equals x, but we have this exponent of 2. When the largest exponent is an exponent of 2, that's what makes it a quadratic. So this entire unit is going to kind of gel and go together much better than the first unit because it's all about quadratics. It's all about x squared, okay? So where we're going to start is transformations. So before we jump full into new transformations, let's remind ourselves what h and k do. So we've talked about it back in Unit 1. We talked about transformations of h and k. What I would like for you to do is you could pause this video and just think about what do h and k do. So things that I would write down is I would maybe write down h and maybe talk about location of h and what are all the things that h can do. And then I would write down k, talk about the location of k and all the things that k could do. So take a second, think about it, write it down, write down everything you know about h and k. Okay, so h, things we know about h is, first off, its location is always inside parentheses. It is located inside a parentheses. Some sort of grouping symbol is where h is located. H is going to be a transformation that's going to slide the graph left and right. It's going to move things left and right. And the key thing there, and you maybe want to put a star next to it, is h works in opposites. So if we see a positive number, we're not going to move in the positive direction. We're going to move in the negative direction. If we see a negative, we're going to move in the positive direction. It works in opposites. See negative, go positive. See positive, go negative. That is what h is going to do. Then we have k. K is located in the back. It's at the end of the function, located in the back. And what k is going to do is it's going to slide our graph up and down. There is no opposites to it. It just slides it up and down. So today, we're going to add on another transformation. There is another piece, and that is A. That is A. Now, before I just flat out tell you what it does, I did a little short thing on like, hey, you try and figure out what A does. So what we're going to do is I have several equations here, starting here, that are going to mess around with A. And all we have to do is I just want to graph it in a calculator and just see what's going on. We're going to graph it in a calculator and say, oh my goodness, here's the transformation I think is going to happen, and then we'll write it all down in our notes. So what we're going to start with is our original graph. This is the parent function, y equals x squared. This is the very baseline graph, and then we'll start messing with transformations of A. So in a calculator, if you go to y equals if you go to y equals, that's this top left button, we need to type in x squared. So the x button is right next to alpha. It says xt, there's a theta and an n. You hit the x button, and then we want an exponent of 2. So what you could do is right above the division sign is your exponent button, and put a 2. So that is y equals x squared, and we can graph it. Okay, we can graph it. When I look at my graph, it is centered right at 0, 0. Centered right at 0, 0. This is the original graph. Okay, so as I work through these other 3 problems, I'm thinking about this as my original and think about what changes happen. Okay, so that's my original. I did kind of a rough sketch for it. Then I'm going to move on to this y equals 4x squared. Y equals 4x squared. So I'm going to go back to y equals. Instead of having an x squared, I'm going to clear that out. I'm going to type a 4x exponent 2. 4x squared. And when I hit graph here, I want to kind of pay attention to what is changing from this graph, the original, to this new one. So I hit graph, and there it is. Now I'm going to draw just a very, very quick rough sketch to be like, huh. So when I look at that, it looks quite a bit skinnier there, like so. Then I'm going to move on to my next one, y equals 1/2 x squared. So I did a number of 4 in the front. Let's now switch that to a 1/2 x, oops, that worked out, 1/2 x squared. So I have 1 over 2x squared. So I'm tweaking with that number in front. Did have a 4 in front. Now we have a 1/2. Hit graph again. And, okay, so this one got a little bit kind of skinnier and taller. This y equals 1/2 went a little bit wider like that. Kind of flattened out a little bit. And then our final one, I have a y equals negative x squared. So I'm going to go back to y equals, type in, not a subtraction sign, I'm hitting this negative symbol, x squared, negative x squared. You hit graph on that, and my goodness, we are now down here. Okay, so what we have done is we've kind of messed around with this idea of A. We've messed around with this idea of A. Now, I would kind of draw this out a little bit more if I was there in person, but since we're video notes, I can't draw this out forever. What I would be trying to think about is I'll be thinking about, first off, where is it located? And see if I could find A here. And I'm going to tell you right now, the number, the number just does something, and a negative sign does something else. So we got to pay attention for A. We can think about its location, what do the numbers do, and what do the negative signs do. So those are things I would be thinking about if you want to discover this on your own. So maybe take a second and think about, you don't need to write it down. You can wait till I write down stuff. But think about, where is A located? What do the numbers in front do? So when we had a 4 here, what did it do to the graph? And when we had a 1/2 here, what did it do to the graph? And then think on this last one, when there was a negative sign, what did that do? So maybe think about, where's A located? What are our numbers doing? And what does a negative sign do? And we're going to write down all these answers. So for the location, A, H is inside of parentheses, K is in the back. The location of A is in the front. A is a transformation that is located in the front of the equation. If you notice, there's a 4 in front. There's a 1/2 in front. There's a negative sign in front. A is always located in the front. The number piece is a little bit difficult. So we have, on this one, we had a 4 out front, and things got, if you think of your arms as a parabola, it kind of went a little bit higher like that. Where when the number in front was 1/2, instead of going like this, we kind of went like that, okay? So if you think about those, obviously you're not going to sit there in class and do this same thing, but when we had 4, we went like this, and 1/2, we kind of relaxed a little bit. How we could describe those is I am stretching my arms out, and then I'm kind of shrinking my arms down. That is the actual vocab we use with A. So here's what's happening. Right now, I'm not worried about the negative sign. That's a completely different thing. We're just focusing on an actual numerical value out front. So when I see 4, what's happening is if that number out front, like 4, is bigger than 1, this is called a vertical stretch. A vertical stretch. So with our parabola, we might have our parabola like this with my arms. Vertical stretch is they get a little bit tighter and go a lot higher. That is a vertical stretch. When that number out front, we don't have to worry about the negative sign about it, just is it a number less than 1, like a fraction of 1/2, 1/4, 1/3, stuff like that. When the number is less than 1, what we saw is we had our original graph, our original parabola, and things kind of shrunk down. They got lower. So we have a vertical stretch and we have a vertical shrink. Those are the two things that the numerical values of A can do. Now, what the negative sign is going to do, you kind of notice all these graphs were opening, and all of a sudden, oh, what happened here whenever we had our negative sign? What the negative is going to do, is you could describe it two ways, is it is going to flip the graph. The more technical way of describing it, it is reflecting over the x-axis. It is reflecting over the x-axis. So the graph was on top, but because this negative showed up, the graph went down. Okay, so if it's positive, we're going up, negative, we're going to go down. So we're going to reflect over the x-axis, so flip over this axis, reflect over that x-axis. That's what the negative sign is going to do. So we got to be careful with A. If you have a negative sign, it's doing this, has nothing. The negative sign has absolutely nothing to do with stretch and shrink. So if you see a negative sign, deal with this guy, set it and forget it. And then look at the number left behind without any negatives. If that number is bigger than 1, it's a stretch. Number is less than 1, it is a shrink. So we'll get through these bottom 4 examples in this video. What we're going to do is we're going to be given the parent function, f of x equals x squared. We're going to identify the transformations that follows from the parent function. So basically, we need to describe what are all the numbers doing, what are all the numbers doing in these equations. So when I look at this first one, this is my original function. So we're starting with x squared. We now have a new one. So I have 2x squared minus 5. So the first number I see is that 2. I see that 2 out front. I'm thinking about, as far as h and k, it's all about location is where I start, and then I figure out the transformations afterwards. So that 2, since it is in the front, of that equation, that is an A. That is an A. We're located in the front. So when I see 2, I'm looking at, it is a number. It is a number bigger than 1, so that 2 is a vertical stretch by 2. It's a vertical stretch by 2. That explains this big 2 out front. The second thing I see is I see an x in that tiny exponent of 2. When I see that tiny square there, that is not a transformation. That is just what is making this a quadratic. So we don't need to explain the tiny 2 there. That's just what makes this graph a quadratic. It's what makes that parabola. So we don't need to describe that tiny 2. The other number I see is this minus 5. So again, I'm thinking about location. That minus 5 is located in the back. So I'm thinking, oh my goodness, it is a k because we're in the back. We are not in parentheses. I know k is going to slide us up or down. So when I see a minus 5, I'm going to write down that we are going to slide down by 5. Slide down by 5. Wow. Okay. Since I've described all the numbers there, I have completed the transformation. A little bit faster now to the right one. H of x equals 1/2. Then I got a parentheses x minus 3 squared. Same deal. I need to think about and describe every single number throughout the equation. First number I see is a 1/2. Now think about that location. I am located in the front. Since we are located in the front, that is A. I got a 1/2 in the front. So since it's a 1 over 2, I don't need to worry about flipping or reflecting because there is no negative sign there. But I do need to think about a vertical stretch or vertical shrink. Since 1 over 2 is 0.5, 0.5 is less than 1, this is a vertical shrink. This is a vertical shrink by 1 over 2. Vertical shrink by 1 over 2. The second number I see there is that 3. Again, think about location, location, location. I'm thinking about, oh my goodness, we are inside of parentheses. So we're either sliding left or right, and we do work in opposites. We are in H there. We are located inside parentheses. When I see a -3, we got to think about, all right, sliding left and right, but it does work in opposites. So if I see -3, I'm not going to go in the negative direction. I'm going to go in the positive direction and slide right by 3. Slide right by 3. That tiny exponent of 2 I do not need to describe. Again, it is that tiny exponent of 2 that is making this a quadratic. So it is not an A, it is not an H, it is not a K. It's just what makes this a quadratic. 2 problems left in this video. So to the bottom left one, you could probably pause me if you want to try these on your own. Or if you're like, nah, I'm going to stick with you, that's fine. But you could probably try those last 2 on your own without me now that we know what H and K are doing. But here we go. I'm looking at this bottom left one. I see a negative x squared plus 3. So a little bit faster now. The first thing I see is this negative dangling out front. Again, the key word there is we are in the front. And what I know is A's are out front. So when I look at the A position out front, I see a negative sign. So I do not need to worry about a vertical stretch or vertical shrink. I just go straight over here to, hey, I see a negative sign. And what I know is it is going to flip it or reflect over the x-axis. So I'm going to write that down. Reflect over the x-axis. That explains the front number. Second thing I see is this 3. So I got to think, all right, I already know what my A is. So is this an H or is it a K? We know H's are inside of parentheses. I don't see any parentheses. It does look like we're in the back, so that is a K. So what I know is K is going to move us up or down. If I see a +3, that is a slide up by 3. Last problem here, it can be a little bit tough. We have L of x equals negative 2x squared. Negative 2x squared. Got to describe my numbers there. If I'm looking out front, this one's a tricky one. We are out front, so we are talking about A here. So when I'm out front with an A and I see a negative sign, so let's just start. I see a negative and a 2 there. I'm just starting by describing first the negative, then we'll deal with the 2. Since I see a negative, can skip straight past this, don't care about that yet. The negative sign is going to reflect it over the x-axis. So let's put that. Reflect over the x-axis. I have explained the negative part of this problem. What I got to explain still is, well, what is the 2 doing? So we're still out front. It is still in A, but now don't worry about this. We're over here. Okay. Now, when we're dealing with the number aspect, do not worry about the negative part. We're just looking. That's why I'm covering it up. We're just looking at a 2. So when you have a number like 2 out front, that is a vertical stretch by 2. Vertical stretch by 2. Okay, that is the first page of our notes. If you missed anything, you could rewind it, play it again, get what you need for that first page.